Hello everyone, this is Mr. Underkoffler. Today we're looking at the guided notes called Relative Frequency and Experimental Probability. Alright, follow along as I read this out loud. Probability is the chance that an event will occur. A simple event is one outcome or one collection of outcomes. For example, an event can occur when tossing a coin, spinning a spinner, or choosing a card at random from a stack of cards. When you perform one of these tasks, you are conducting one trial of a probability experiment. The relative frequency. Okay, here's a first major vocabulary phrase. The relative frequency is the number of times an event occurs divided by the total number of possible outcomes. Okay, here is the fraction that we are going to set up for relative frequency. The numerator will be the number of times that the event occurs. The denominator will be the total number of outcomes in the situation. For example, problem number 1. Carlos plays a card game that includes the cards shown in this table. He randomly selects a card, records which type it is in the table, and then returns the card to the stack. He repeats these steps 75 times. And by the way, if you add these numbers, this would give you 75. Okay, based on Carlos' results, what is the relative frequency of selecting a resources card? Write the answer as a fraction in simplest form, a decimal, and a percent. Okay, so we're looking for the relative frequency of selecting a resources card. Okay, resources card showed up 30 times. In fact, if you're not sure what the word frequency means, it means how frequently did something occur. That's the word frequency. The phrase relative frequency, as we've already mentioned, will be the fraction where the numerator is the number of times the event occurred and the denominator is the total number of outcomes. Okay, we already know the total number of outcomes. They told us it. It was 75. And if you added these numbers together from the table, it also would have given you 75. So that is the denominator of your fraction. And guys, the denominator for any kind of probability problem will always be the total number of outcomes. All right. How many ways did the event occur of getting a resources card when Carlos randomly picked a card at random? Well, it happened 30 times, so the numerator is 30. Okay, this is not in simplest form. Hopefully you guys know simple little divisibility tricks. If both numbers were even, they'd both be divisible by 2. If both numbers had sums of multiples of 3, like 3 plus 0 is 3, that's divisible by 3. 7 plus 5 is 12, which is also divisible by 3, so that means these two numbers are both divisible by 3, but also it ends with a 0 and a 5, so they're both divisible by 5. Since they're divisible by 3 and 5, you might have recognized these are both divisible by 15. But wait a minute. You also might want to sometimes use your calculator. Your calculator has a fraction key. So do this right now. Don't hit the division key for the fraction bar. Hit the fraction key button. Type in 30 over 75. Hit enter, and it should reduce it for you to 2/5. Now, if you don't have a fraction key on a calculator, you could have divided the 30 and the 75 both by 15 to get 2/5. You also could divide 30 by 5 and 75 by 5. That would have given you 6 over 15, and then 6 over 15, they're both divisible by 3, giving you 2/5. So there's many ways to reduce a fraction. I am not going to prevent you from using the fraction key of your calculator, so if you would like to do that, fine by me. Okay, to get the decimal, yes, there's a function on your calculator that might be called f to d, fraction to decimal, but you can just simply take 2 divided by 5. Take the numerator divided by the denominator, and that's going to give you the decimal, 0.4. I hope you're writing all this down with me. And then for the percent, to go from decimal to percent, really easy. You basically just multiply by 100, because percent means out of 100, or you move the decimal point 2 places to the right, because there is a place value called the hundreds, and that is the second digit after the decimal point. Percent means out of 100, so if you move the decimal point 2 places to the right, that will give us our percent. Boom, 40%. Make sure you have all three of these answers written down because the directions required all three versions of the answer. Okay, problem number 2. This time we do not have a table. Read it with me. A number cube. Now, let's start right there. You're like, what in the world, Mr. Underkoffler, is a number cube? Well, it's a cube where every side shows a different number from 1 through 6. You're like, don't we normally call that a die, which is, if there's more than one, we would call them dice? Well, a lot of textbooks don't say dice anymore. I heard a rumor that many years ago, textbooks were accused of encouraging kids to gamble by using the word dice. I don't know. I don't know if that rumor is true or not, but a lot of textbooks will use the word number cube. It's kind of like a die, but instead of having the little dots for the dice, it is actual numbers printed on the cube. So bear with me. We're going to hear this phrase number cube a lot in this unit. A number cube with sides labels 1, 2, 3, 4, 5, and 6 is rolled, this is important, 20 times. That's the total number of outcomes. So if you want to go ahead and start setting up your fraction, you may. Denominator is going to be 20. The number 5 is rolled 4 times. So instead of giving us a table of values, they're actually explaining it in the paragraph, in the sentence. What is the relative frequency of rolling a 5? Okay, don't put a 5. There were not 5 5s. They got the 5 4 times. So the numerator is not the number 5. The numerator, if I can go back to the top of the page here, is the number of times the event occurs. The 5 occurred 4 times, so that is your numerator. Okay, we're going to write our answer as a fraction in simplest form. This is not in simplest form yet. A decimal and a percent. Okay, you could probably reduce this fraction without a calculator. They're both divisible by 2. That would give you 2 tenths. But 2 tenths would still both be divisible by 2, which means you actually could have divided 4 and 20 both by 4. 4 divided by 4 is 1. 20 divided by 4 is 5. So don't do the really easy fractions with a calculator. Try to do them without a calculator. Okay, 1 divided by 5, you might have this one memorized. 1/5 is 0.2. If you did not know that, you could have done 1 divided by 5 in your calculator and got 0.2, but some of these you should probably start memorizing at this point in 7th grade. And then to make 0.2 become a percent, 0.2 is the same as 0.20. We move the decimal point 2 places to the right. That's going to give you 20%. The reason I circled all three of those answers is because the directions asked for all three forms. And spoiler alert, the directions on this packet of guided notes are not going to always ask for all three forms. They might only ask for 2 of them or only 1 of them. So please make sure you always read the directions of each unique problem. Okay, now that we've done numbers 1 and 2, why don't you quickly hit pause, read number 3, and do it on your own, and then hit play when you're ready to see how you did. Okay, problem number 3. I assume you already did it on your own. You saw that the total spinning amount of times was 24 times, so that's your denominator. We're trying to find the relative frequency of spinning a vowel, and I know there's only 2 vowels here, but they spun it 24 times, and 9 times they got a vowel. So I hope you didn't put 2 here. We're looking at the actual number of times the event occurred, and that was 9 times for the vowel. Both 9 and 24 are divisible by 3, and that would give you 3 eighths. I don't know if you have your eighths memorized yet, but it's 0.375 when you take 3 divided by 8, and that makes it 37.5%. No, we're not going to round that to 38%. No. Didn't say it around. You're totally allowed to have decimal parts still in your percent answer. So please, no rounding unless the directions tell you to. Okay, next page, problem number 4. This time we got a very creative looking table here with animals. Let's read about this. A group of students went on a field trip to the zoo. The frequency table shows the results of the survey about their favorite exhibit, which means some kind of place that showed animals. What is the relative frequency of the favorite exhibit being either penguins or bears? Let's stop right there. Here's something you might not know about probability and relative frequency. When they ask you to find the probability or relative frequency of something or something else, it doesn't mean you pick which one you want to pick or to give two separate answers. It actually means those two types combined. Ladies and gentlemen, you might want to highlight this or underline this. So the word or means those two types combined. And so what you're going to need to do is add their amounts together. So let's do that. For the bear, there were 6 bears. For the penguins, there were 13 penguins. And so some simple addition, that's 16 plus, or I can't speak today. 13 plus 6 is going to give you 19. That's your numerator. Oh, what's our denominator? What's the total number of people who participated in the survey? They never really do tell us, but if you do some simple addition here, you can use your calculator if you really want to. 6 plus 17 plus 21 plus 13 plus 13, boom. That's going to give us a total of 70. That's the total number of possible outcomes. So that is your denominator. All right, that is already in simplest form. If you don't believe me, you can think to yourself about what 19 could make. 19, 38, 57, going on from there. It's not going to ever make 70. So that is in simplest form. You also could enter it into your calculator, and if you hit enter and if it doesn't change, then that also guarantees it's already in simplest form. Okay, what else did it want other than the fraction in simplest form? Oh, it wants the percent rounded to the nearest tenth. Okay, so we're going to take in our calculator 19 divided by 70 gives you 0.2714, right at least 4 digits. If you're going to round to the nearest tenth of a percent, because the tenth of the percent will actually be in the thousandths place, which will eventually be the tenths place after you move the decimal point 2 places to the right. So that's going to be 27 point. All right, this is why I wanted you to put 4 digits. You have to look at the 4th digit to figure out what you're going to round the 1 to. Is 4 big enough to make the 1 round up? No, it is not. So about 27.1%. And the reason I only circled the fraction in simplest form and the percent and not the decimal is because the directions only ask for the simplest form of the fraction and the percent rounded to the nearest tenth. Okay, why don't you go ahead and try number 5 on your own. Hit pause now and do number 5. Okay, did you already do problem number 5? If not, you better hit pause now. All right, we are trying to find the relative frequency that the favorite activity is going to be either track or football. As I mentioned before, when you see the word or, you are going to add those two quantities together. So football's number is 21, track's number is 4. Adding those together, you're going to get 25. Adding all of these frequencies together, you're going to get a grand total of 75 possible outcomes. So there is your fraction, but that is not in simplest form. If you think quarters, 3 quarters would make 75 cents. So this does reduce to 1/3. You could probably do that without a calculator. I've told you guys actually a little bit earlier this school year that you should start memorizing what your thirds are as decimals. 1/3 is 0.3 repeating. I was about to go into percent area. Yeah, 1/3 is 0.3 repeating. 2/3 would be 0.6 repeating. Anyway, taking the decimal point, moving it 2 places to the right, please don't say 30%. There's not a 0 next to this. This is a repeating 3. So don't say 30%. Don't say 33%. It's still a repeating 3. It's 33.3 repeating percent. If you got that wrong, please fix it now. Okay, I'm actually going to stop the video at this point. We're about halfway through the guided notes. I'm going to do part 2 in a separate video. So thank you for watching this one. We'll see you next time.